this week, Hamid Mahmood, who is an awesome iOS engineer with us, is going to give us an overview of Async Await with all the best practices and use cases in Swift. So without further ado, let's get it started, Hamid.
Yeah, hello everyone. Welcome to another lightning talk. Today's lightning talk is based on iOS platform, iOS and Apple related platform, covering Async Await. Uh, Starting off from what async await is. So basically, async is a keyword introduced in Swift, uh, which stands for asynchronous and can be seen as a method attribute, making it performs asynchronous tasks. So asynchronous is what is asynchronous? Basically, asynchronous is a non-blocking architecture where you can execute multiple tasks without depending on one another, and those tasks can still run simultaneously on the system by sharing the thread. In Swift, since this is more Swift-oriented and iOS-oriented talk, so I will be covering async await or asynchronous task architecture, more focusing on the iOS and basically Swift language. So very easy to use the keywords with the functions. Normally, whenever we perform a task in any programming language, we normally do that in form of functions or methods. In Swift, you can make a task, make a function asynchronous by running multiple tasks inside that function. Just use a async keyword next to the function name, and wherever you call that function, just use the word await, and that's gonna fulfill the purpose of using async await. Um, Await keyword is used for asynchronous methods by putting before the method name where you're calling. Basically, what does await do with if I dig deep dive into the internal mechanism of await? Await makes the tasks, the executing tasks, to do whatever it's doing and give the control to the system. Once that task finishes, system can give the control back to the function, and function can resume from where it suspended the execution of the instructions. Uh, Async await is introduced starting from iOS in Swift 5.5, and iOS is supporting it in iOS 15. macOS, watchOS 8, tvOS 15, but as soon as 13.2 Xcode was released, they provided backward compatibility for async await, which is great. Uh, in that case, already the existing code can also be converted into async await, means the functions which were not using async await, they were not following in that domain, are able to be converted into async await. So technically, iOS 13, watchOS 6, tvOS 13, and macOS Catalina now officially support async await. What are the benefits of using async await? The amazing thing that came up is structured concurrency. I'm going to explain it a little bit in next slides. So structured concurrency has increased the performance and responsiveness of the overall application, especially when you have long running operations. You have more than one instructions, that each instruction is doing a long running task inside one method. That's where you can just apply async, and wherever you call it, just apply await. Rest the Swift system, iOS is going to take care of that. Organize and neat to be readable, very, very clean code, very less code and short code, very safe. No need for completion handlers. That's a big thing. With async await, we don't need completion handlers or escaping closures. Basically, so let me give you an overview of the completion handlers. Previously, when we were performing any asynchronous tasks before async await, we were doing that in form of completion handler. So completion handler is a high order function that is just being passed inside of another function as an argument, and that escapes once that function actually finishes its execution. Now we don't need completion handlers anymore or escaping closures in Swift with this async await. Structured concurrency. So structured concurrency means we don't have to manually propagate errors and manage cancellations. If execution continues normally after a call within a group of tasks, we can assume that all of its child tasks completed successfully. That's mean with a structured concurrency, you will go step by step. You don't have to switch between closure to closure or completion to completion. Once specific instructions are executed, and we get the value back, that's mean all the child processes are already finished on that thread. Structured concurrency with async await method calls make it easier make it easier for any long running tasks, and as well as even if you're running instructions that share more than one threads or multiple resources. Methods are linearly executed without going back and forth. As I mentioned, in case of completion handlers, it's the other way around, which is great. That's why we call it execution of instructions or concurrency in a structured manner. Async gives an ability to suspend the task and its callers as well. As I mentioned, if there is a long running tasks or there are multiple instructions inside one method, and let's suppose there's URL session running in a method, and no one knows that how long the URL session is going to take and return the value. In that case, that method would be suspended, and the control will be handed over to the system. And once that task finishes, that function resumes its rest of the completions. Await decides when and where and how many times a function can suspend. The await keyword that we're just putting before the function name at the caller place or into the caller method. When async function is suspended, thread is not blocked, which that's why we call it a non-blocking architecture. And then in that case, once a task is being suspended, and system has gotten the control, now that system can schedule another task till the previous task finishes, and it just resumes back again and give the control to the function. As soon as awaited tasks are executed, functions resumes. Pretty simple and straightforward. Counterparts. We have combine, completion handlers, async await. Like these three techniques were used and are used to call any HTTP request or perform any asynchronous tasks. Like combine is a whole lot another reactive framework. I'm going to cover the difference here. With async await, there is a structured concurrency pattern. Methods are linearly executed without going back and forth, like with completion handlers. Now you can see like what's the difference between completion handler and async await method of making the HTTP requests. So you don't need completion handlers at all. Just follow that structured procedure of concurrency. There is less code to write with async await. True. I'm going to show that in Xcode very soon. Combine also performs asynchronous tasks under the hood. The combine need dispatch queues. So before the async await, completion handlers were strictly using dispatch queues. Basically, dispatch queues are nothing more than just an architecture provided where multiple multi-threaded tasks are being performed based on what thread they're running on. Let's suppose if there are user-initiated tasks, they're going to run a queue, which is the main queue. If there are any background running tasks, any downloading stuff or anything, those are going to be running on the background queue. So all those queue types were actually coming from the dispatch queues. But with async await, we don't need to set any dispatch queue, as in case of combine. Just give it async and type await before the function, and rest the async await architecture is going to take care of that in the Swift. With async await, just marking a function with a main actor. As I mentioned, like in combine, we're using dispatch queue. We are giving it a queue like main background based on the quality of the service dispatch queue is offering. But with async await, all we need to do is just mark the function as a main actor, and your task is just going to be taken care in the main thread. Combine is also an Apple's native framework, which is a reactive framework. So combine is more than just having just having to make the calls for the network. You can do way more than just calling HTTP requests and getting the data back. So RX Swift, if anyone is familiar with RX Swift, that was a framework that still existed, and so many projects are still using it. It's similar to that. So when I say reactive, it's a framework based on highly based on observer pattern, using publishers, subjects, subscribers, emitting streams of data, and one can definitely leverage to design a notification center or a notification-based framework, and heavily rely on combine pretty simple data fetcher, which is fetching its data from JSON placeholder, public data, dummy users data. There's a user model for that, includes name, username, email address, and address, and then company name, and all. It's all dummy data, actually. So just for the purpose of showing up how data is coming through the async await, that's why I just took this placeholder. If I go into the actual fetcher function, what's happening in this function? I am trying to. Okay, so this function is marked as async